Hello, this is Group 2 from the K Division in the first year in VIT Pune. In this video, we are going to explain Booth's algorithm. Now, what exactly is Booth's algorithm? So, Booth's algorithm is a method for performing multiplication of signed integers. It is a modified version of the standard shift and add multiplication algorithm. It was invented by Andrew Donald Booth in 1950 while doing research on crystallography at Birkbeck College in Bloomsbury, London. It is particularly useful for multiplying two signed numbers represented in 2's complement form. It is of great interest in the study of computer architecture. Now, let us look at the prerequisites for using Booth's algorithm.
So you need to know how to calculate 2's complement before understanding Booth's algorithm. The first step is to convert the given decimal or hexadecimal number into binary. Next, we find the 1's complement of that binary number. 1's complement is nothing but replacing 0 in place of 1 and vice versa. Then we add 1 to the result to give 2's complement. Thus we have calculated 2's complement of a given number.
Let us understand the Booth's algorithm using a flowchart. As you can see, the multiplier and multiplicand are placed in the Q and M registers respectively. There is also a 1-bit register placed logically to the right of the least significant bit of the Q register and is designated as Q minus 1. The results of the multiplication will appear in the A and Q registers. A and Q minus 1 are initialized to 0. As before, the control logic scans the bits of the multiplier one at a time. Now, as each bit is examined, the bit to its right is also examined. If the two bits are the same, that is either 1 1 or 0 0, then all of the bits of the A, Q and Q minus 1 registers are shifted to the right 1 bit. If the two bits differ, then the multiplicand is added to or subtracted from the A register depending on whether the two bits are 0 1 or 1 0. Following the addition or subtraction, the right shift occurs. In either case, the right shift is such that the leftmost bit of A, namely an minus 1, not only shifted into an minus 2 but also remains in an minus 1. This is required to preserve the sign of the number in A and Q. It is known as an arithmetic shift because it preserves the sign bit. As it can be seen, the Booth's algorithm works with any combination of positive and negative numbers.
Hi, I am Pushkar. To have a good understanding of Booth's algorithm, we'll go through a example of Booth's algorithm. Here, M is multiplicand, Q is multiplier, N is number of bits, which is 4. Initially, A is 0 0 0 0 and Q is 0 0 1 1 and Q minus 1 is 0. By looking at the last digit of Q and Q minus 1, it is 0 1. So, by the Booth's algorithm, A will be A minus 1 or addition of second complement to the A. Then A will become 1001, then shift it right as number of cycle 2, last digit of Q and Q minus 1 is 10. So, by using the algorithm, A will be A plus 1 and then shift it to the right and so on for the next steps.
It's just the simple multiplication. When we multiply 1 with the whole line, we get the answer. Then for the second line, we have to leave one space and multiply the second one with the first line again. Then for the third one, leaving two spaces because as it is 0, then we'll get all the zeros, and we have to follow the same process again and again. At last, when all the process is done, we get the answer, and that is to be converted into decimals, and we get the final answer, which is 437 in the above example.
The advantages for using Booth's algorithm for multiplication are as follows. It can handle both signed and unsigned numbers. It has very low hardware requirement and is very fast and efficient in terms of time and computation. The disadvantages are that it is only limited to binary numbers. It has high complexity for larger numbers. There might be rounding errors for larger numbers, and it is not suitable for floating point arithmetic.